Hey guys, welcome to Piecewise Functions. This one's actually going to be a little different. I know you have a graph beside yours and you guys are on the right sheet. It's all good. Basically, this equation doesn't fit on this graph with this constraint, so long story short, I had to change the problem a bit, but that's okay. That just means you guys get to see one of these before you try one on your assignment. So what we're going to do is kind of treat these as their own separate equations. So this one is y equals 3x minus 4, and that's only true when x falls between this sort of constraint, all right, or rule, if you want to think about it that way. Y equals negative x minus 1 if negative 6 less than or equal to x less than negative 1. And then last we have y equals 4 if x is greater than or equal to negative 1. Okay, so each of these has its own rule, and all it really means is you use this equation when this is true. You use this, if you guys want to write that, I probably would. When this is true. Okay, so that's definitely a great way to think about it. And it's not just this one, you use this equation when this is true. You use this equation when this is true. All right, so I'm gonna help you all out with this one, and then I'm gonna let y'all try one of these. So you guys have done this before, whenever it said something like find f of 5, find f5, if you wanna say it that way. And then it gives you an equation like f of x equals 5 plus x. And you know that f of x, 5 is in place of x, so 5 must be x. And that means we just simply substitute 5 where we see x. So 5 plus 5, f of 5 is equal to 10. All right, kind of the same thing with these, except we just have a few more equations we have to worry about. Or we have a set of rules. Like basically, for f of 2, we're going to use one of these equations. We're not going to use all of them. We're not going to just use the top one because it's the top. We have to think about it a little bit. So f2, you have to first see where this number falls in. Which of these does it fall in? Whichever is true, you're going to use that given equation. Okay, so 2 is not going to be less than negative 6. If you want to, you can do a kind of a number line here. We have negative 6 and 0, and we have 2. So less than negative 6 would be that way. So it's not that one. I know it's not that one. Negative 6 and negative 1. Well, there's negative 1. 2 is not there, so it's not this one. If x is greater than or equal to negative 1, well, that's everything this way. And it's definitely going to be this one. So f of 2 equal to, we have to use their equation, and this just simply says f of x equals 4 if this is true. So is this true? Yeah, we know it's true. So f of x equals 4, or y equals 4 when x is 2. F of negative 1, we're just going to see where negative 1 falls with each of our constraints. So if you want to do a number line, there's a couple key points I know I'm using. All right, so negative 1, is it that way of negative 6? Definitely not. Negative 1, is it in between this and this? So that would be an empty and a closed circle. Is it in between that? Almost. If that was closed, it would be. This says if x is at negative 1 and everything that way, you use this equation, f of x equals 4. So again, f of negative 1 equals 4. You guys try this one. See if you can get f of 0. Okay, you should have first tried to see where 0 falls. Does it fall in this kind of area, or does it go between here, or does it go in this one? So I hope you were able to see it definitely is this one again, and it's gonna be 4. F of -6, I want y'all to try. Give that one a try. Your first step is to see where -6 falls. So this says x is less than -6. So empty circle, and it's everything that way. -6 is not included there, so it's not this one. This one says if -6 included, so it'd be a closed circle, through -1, and it's an empty circle. Oops, we know it's an empty circle. Don't worry about that thing. So yeah, it's definitely gonna fall in between this one, which is what, -x minus 1. So you should have used f of x equals -x minus 1. And we need to find f of -6. So if you didn't know how to do that, this is how you do it. We know that -6 took the place for x, so it's gonna take the place for x again. How you wanna think about these is, first of all, f of x we know is just a fancy way of saying y. F of x is y. So each of these is its own equation. For example, this one is y equals 3, which we know how to graph that. Y equals 5. And y equals 8 right there. And then you have at the end, you have y equals 10. And what I like to do, instead of this word if, instead of that word, I like when. Because instead of if, it's actually when. In other words, this graph, we're gonna graph it y equals 3 when we're between -1 and 2 for an x. Or in other words, when we're between this, maybe I should keep the same color, but when we're between this and 2 would be right there. So that tells us exactly how to graph that part. These are each separate parts or separate graphs that come together. Okay, so y equals 3, it starts at -1, and it is inclusive because it's got or equals to. So is that open or closed? Yeah, it's definitely gonna be closed. It's gonna be closed at -1 as an x, but y is 3. So x of -1, y is 3, okay? Because y equals 3, that's a horizontal line at 3, at +3. All right, so it's gonna start here, it's gonna be closed, and it's gonna go to +2. Also, ooh, I messed up. That should be open, guys. I'm gonna make it open. Okay, so somewhat looks open there, at least. I'll make this one real big, and that way it doesn't look too bad, I guess. Anyways, y equals 5 when we're between 2 and 4 as an x. These signs, again, very important, so don't get ahead of yourself like I did. Y equals 5, when we hit 2, it's closed. So there's 4, there's 5, and this one is closed because it wouldn't be a function if both of those were closed. So this is stretching from 2 to 4, and the 4 is gonna be open. Y equals 8 when 4 less than or equal to x less than 9. So y equals 8, that would be 5, 6, 7, 8 up here, and it starts at an x of 4. So right where we left off, this one's closed and it goes to an x of 9, which is right there, and it's open at 9. I know that because it doesn't have or equals to. If it was this, it would be closed. If it's this, it's open. All right, here we go. Y equals 10 from 9 to 12. Okay, and this thing doesn't even go to 9 or 12. Well, it goes to 9, so we can do that, I guess. So right there, it's gonna equal 10, and that's a closed circle. And that x of 12 would be somewhere over here, so empty circle. It looks like that. Takes a little bit, but mainly just talking about them takes time. G of x, what does g of x stand for? Yeah, it stands for y. So go ahead and write that. G of x is y. Anything of x is y. Anything, even if it said h of t, it's just y. This is saying y equals 5x minus 1 when x is less than 2. So how you want to do these, you want to basically graph it in pencil, just like you would if it was one single equation and you were going to graph it. So we're going to go down 1, that's a point because it's our y-intercept, and it's a slope of 5, so 5 over 1, up 5 over 1, or up 5. So we go up 5, right 1, up 5, right 1, and that's when x is less than 2. We'll get to that in a second. We could also go down 5 and left 1. This is where this is going to come in. All right, we know we don't have, this isn't inclusive because it's not or equals to. So x is less than 2. We have an open circle at an x of 2 for this graph. So it looks like that. And it's still the same line, but we don't have this graph this way. We don't have this graph going this way because it's only this when x is less than 2. So at 1.99999, we have this graph. At 2, we do not, and that's why we leave it open. All right, so we would just graph this just like normal, and it's going on forever, just like it would, because it's linear. All right, and now we're going to use this graph for this constraint. So y equals x minus 9 when x is greater or equal to 2. So x minus 9, I know we have a y-intercept at -9, and our slope is 1, or 1 over 1. So that's going to be right here. And it's just going to be kind of like this. But this is only true at 2, so we have a closed circle. So that means we can just go ahead and get rid of this because we know we don't have anything that way of 2. But we do have something at 2. We have a point there. So a closed point here, our open point's up there, and it makes sense because our closed point's here. And this one's going to go on forever this way. So that is exactly how that one should look. Okay, let me do one of these. We have f of x is equal to x plus 3 if x is less than -2. So where do you start with this? And it's going to be like that. And I know we don't have a point at -2, or we have a point, but it is empty. So it's going to be right there. And this graph would look like this. Okay, so that one's good. And for this -2x minus 3, we have this constraint. So y equals -2x minus 3. That would be a y-intercept at -3, which is right there, and a slope of -2 over 1. But that's only this way of -2, okay? And we have a closed point here. So just like that.